that resource.
Right, should we go through that?
Yeah, let's do that.
Right. So there's your first CPI extension module.
Mhm.
Bunch of prerequisites. You need to have pip and a
Let's.
virtual environment.
I don't see your screen if you're sharing it. I'm looking for feeling. CPython tutorial. Now I found it.
Can you see my screen now?
Yeah, now I see it.
Okay, that's the tutorials here. Okay, so we go through this on Fedora and make sure it works on the system, right?
Let's do that.
Right, so we will use the low-level CPython directly, which is not a good idea, but have to start somewhere. You need to know something about Python. Need to know something about C.
Mm-hmm.
Yeah.
There is a tutorial.
We'll focus on the basics. You will not learn anything important. We'll assume you're using Linux or Windows, right? You'll need to have a suitable C compiler and Python development headers. So we do have GCC. We do have Python 3 dev. First devel, right?
Well,
we have pip, but we should have a virtual environment. So I'll make a directory for CPI tutorial, cd to it, and make a virtual environment. Okay.
yes.
I guess with you we wouldn't need to do that, but that's too new. We use CPython 3.15. Okay, so I should make a virtual environment with CPython 3.15. And that's pretty important.
Mm-hmm. So I guess what we're interested in also is Python 3.15 devel.
Right. All the packages are split now, right? Good. Right, so what we'll do, we'll create an extension module called spam, which will include a Python interface to the C standard library function system. This function is defined in stdlib age. It takes a C string as argument, returns the argument as a system command, and returns the result as an integer. Manual page for system might summarize it this way. Okay, so this if you do man system, that's what you'll get. Well, I copied that from Fedora, so that should work.
Mm-hmm.
Many functions in the standard library. This function is already exposed in Python, so you shouldn't really do this for production, right? It should work like this. And we should start with the headers. So module called spam module.c.
Mhm.
There is a footnote. The source file name is entirely up to you. And this file will include Python H and HTML page. This one needs to come after Python H. I'll save that and run the build tool. So our build tool will be mess on Python because that's the easiest to use.
Alright.
You could also use setup tools, but that's a bit quirky. And for that we need two files. PyProject.toml
Mhm.
with named sample project. So this requires MesonPy build backend and the Meson Python package. And there's a project named sample project version 0. We're not trying to distribute anything, so
That should be okay.
we also need meson.build, which has its own syntax, I guess. So this is a project sample project written in C. It also uses Python, and it finds a Python installation that has the development headers available. I guess that's what this means.
Mhm.
Build an extension module called spam from spammodule.c, and it will get installed.
Mhm.
Right, and then if we do python-mpip install dot, everything should work.
Let's take a look if this does advertise this. So, yeah,
Right.
successfully installed.
So we skipped one thing, and that's if we don't want to use Meson Python, there are other build tools in the appendix here, which we'll get to later. And that's where the trouble will be. Now we can try importing this. So if we run Python in the virtual environment, and we import spam,
We'll get.
we'll get a module not found error.
Oh, I've got a different error.
Why? Because I didn't run pip install in the correct virtual environment. Silly me. This is what you get.
That's
Dynamic module does not define module export function. Right?
yes.
Okay, so we define one. First we add a prototype, and then we add the function itself, and it'll just return null for now. Right?
Mhm. So just.
So we compile again and run import spam. I get a slightly different error.
Oh, am I there? So you reinstalled.
Yes, you need to
Current
reinstall it.
directory and imports. What happens? Oh, there's a heaping. Oh, okay, a module export hook. Yeah, I've got the same without setting an exception. So we need an exception.
Right, so simply returning null is not correct behavior, and so CPython complains about it.
Right.
That's good. Apparently this function does something. So now we do the slot table. So instead of null, the function should return the slot table,
Mhm.
which is essentially key value pairs. So we have pymod name, spam, pymod doc, wonderful module, and then an end of the array, null terminated. to make this work, we also need to return this array from the PyMod export function. Alright, import spam succeeds, and if you do print spam, you will get the module. Or you can do help spam and get the doc string.
Trying to get there, yeah. I've got this, I've got print, I've got, I guess, that help too.
Nice.
Yes, I've got it.
Alright, now we need to expose the system function, for which we'll need to write a layer of glue code, which means using something called a metho function, which takes two Python objects and returns 1. Okay? So we're supposed to, right above the slots array, put this simple function. So for now we ignore these two arguments and use a special macro to return the none object. And we'll recompile just to make sure we don't have syntax errors. It doesn't do anything else right now. We might get a warning that spam system is unused. I wonder how we should tell pip to show us the warning.
Oh.
That's a good idea. I should put -v at the pip call.
Yes, do I see it too? Yeah, I do.
So it's an action item for myself. Alright, now we get to module definitions. So, no, method definitions. So to expose this function to Python, we need the name, a doc string, the C function to be called, and flags. All of that is put in a PyMethodDef entry, which is part of a PyMethodDef array, because usually you have more than one function. And after that, what we do is add a slot in the module slots containing the methods. And after that, if you print spam.system, you should get built-in function system. And if you call spam system with a user with a system command, you should get none because we're just returning none.
Built-in function system. I'm here. Everything is right. Oh, I get a syntax error. Yeah.
And
Yeah.
if you use too many arguments, you should get an error. If you use too few arguments, you should also get an error. All that seems to
Mhm.
So the next step will be returning something. Right, so instead of return none, we'll get a C value for what we want to return.
Mhm.
We'll convert that to a Python object. And we'll return that. So if you call the function now, you should get the number 3.
Yes, that's what I get.
And the next part is accepting a string. So we're using meth O, which means we get the module object, which is not very interesting, and an argument. Right?
Mhm.
And that argument is the single argument for the Python function, and it should be a Python string.
Mhm.
There's a function called pyunicode as UTF-8, which will convert that to a C string.
Mhm.
This can fail, so we need to handle errors. So if we get null from this command, then we return null. I think I should move the test for this to this point. So if you call the function with a number instead of a string, returns a result with an exception set. Oh, did I not save it? Right, I didn't save it. Okay, so another action item for myself, I should put this example up here. So remove the wrong type example. Error handling. And now what we need to do is instead of status equals 3, we'll just call the system C function on the command.
Mhm.
And when you call that, you should get your username out.
Yes.
When you call a bad command, you get an error message from the shell and some weird number.
Mhm.
Alright. So it looks like everything works.
It does.
If you want to teach somebody how to create Python extensions, you can go through that. And now, the other build tools. So, I wonder how many of those work on Fedora. So, PyPA recommends setup tools, Meson Python, scikit build core, and maturing, but that's only for Rust. So setup tools, the documentation for setup tools is user guide.
Building extension modules.
Building extension modules, alright. So let's try this.
Alright.
So we should change PyProject toml. So instead of mess on Py, we use setup tools. And for tool.setupTools, for X modules, so there will be a module named spam, and the source will be spam module.c. Let's see if that works. Whoa, it did. Nice. Oh. This worked, that's great. Problem with setup tools is this one will not work on Windows. But that's a setup tools bug.
Okay, how do you know it? Or like, have you tried it?
Yeah, I've tried. So what it does is it tells you that there's a missing function called pyinit spam, which you can just add to make it shut up. So next is mess on Python, which we've just tried. And next up is scikit build core, which I don't think I've tried. So let's try that.
Okay.
So instead of setup tools, how do you do this? So source code. No, this C and API 3. Wow. Let's see, it's API 3. So we'll need requires scikit build core and tool scikit build core. This will say wheel PyAPI CP3.8. Oh, we can't do that yet, sorry. We need to, actually, can we do that, CP3.8? And now we'll need a file called cmakelists.txt, which will say the cmake minimum version is, or minimum and required version is 315 to 326. It uses C, it uses Python, and instead of example C, we should use spam module .c, and the library should be spam, I guess. So let's see, will that work? It will not, because we don't have PyMod methods, right? So the problem here was the ABI3. We should use just plain C, which means getting rid of this wheel.pyAPI. And in the CMake lists, is there a difference?
Yes. In Python add library.
Use SABI, right?
and without free aid.
Targets given target spam which does not exist.
And install.
Oh, Python module is not defined. Oh, there's another difference. There's components development module. Oh, there we go. Okay, now it works. And I wonder if we can do like CP315. So this would use SABI 3.15. Hopefully the extra component is not a problem. No. PyUnicode as UTF-8 is not defined in CP315. Whoa. That is weird.
Can it be it's not part of the stable ABI?
Should be.
Should be. I'm looking at its
Oh, it's not.
station that it doesn't have.
That's a good point.
There's a CPython string function that will return.
That will return a Python byte subject. There's PyUnicode as UTF and size, which takes an extra argument, but that can be null. Okay, so let's use that. Now it works. Alright, so action item number 3. Use PyUnicode as UTF-8 size with null. And let's see what this says. Size argument can be null. In that case, no size will be stored. Buffer has an extra null byte appended, not included in size. Okay. So everything works. That's great.
Hmm.
What you're in, of course, is Rust only, so that won't work. But there's also compiling directly. And I would really like it if you could, instead of all this PyProject TOML and build tools and pip and whatever, just call the compiler and build your module, right?
Mm-hmm.
So this is the case where your system is set up correctly. So what setup tools and all the other build tools do is handle all the edge cases for all the different operating systems, all the ways things are set up. Right? They'll find the headers wherever they're installed and so on. But if your system is set up correctly, and I assume Fedora wants to be that system, it should be much easier, right? So there is a Python 3 config. I guess we need a Python 3.15 config, that's fine. And you should be able to pass C flags and LD flags to it and get everything you need to compile extension modules for your Python. Right? It does not include -- shared, which you'll need to pass extra. So then you do this, and you compile spammodule.c to spam.so, and this does need to be 315. Right? You do this on Fedora, and you'll get an error. It'll tell you blah blah blah, recompile with -fpic.
Yes.
And another error, which is probably a result of the other one. So if you do -fpic, everything works. So you remove spam.so, recompile. I get spam.so, and now I can import spam. I get it correctly and it'll work. Right, so the problem here is the missing fpic, which, well, I think it's ultimately a bug in Fedora's Python 3.15 config. What is fpic anyway?
That's the question.
Means many things.
Consent is important in many contexts.
So there's f small pig and f big pig. The big one is emit position independent code. So I guess the small one is generate position independent code suitable for use in a shared library. Such code accesses all constant addresses, blah blah blah, blah 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 blah. Positional independent codes requires special support and therefore works only for certain machines. Big pig, if supported for the target machine, emit position independent code suitable for dynamic linking. Right, so the difference, I guess, is this if. So basically you should always use fpic. Why is it not the default with -- shared? come the build? Where do the build tools add this?
Yeah, that's a good question.
Maybe we should just put it in the tutorial. I don't know. But this looks like an interesting system integration issue. So if I go back to Maison, does it tell us what it did? No. So which one told us what it did? Was that setup tools? Oh, here it is. So it added strict overflow, sign compare, fpic.
It's there.
Something very different. So do we need fpic instead of shared? No. We do need these includes, but those should come from the Python 3.15 config. Oh, here they are. The includes, all the F things, and even some linker options, which is good, I guess. Compile this without LD flags, yes. Huh. So what's different here? Oh, it compiled first to a .o file, and then it linked to a .so file. And there it put shared.
Mm-hmm. So it's a two-step process.
And some library. No, that's fine. If we don't really need the two-step process, but I wonder how the fpic got there. It should be in the C flags, right? You can't build an extension without it. It should be in the C flags. So let's look at CPython. Does this have an upstream config? Which is probably where you're getting this from, right? Just the upstream file. And fpic is nowhere to be found. Right, so I guess this is the exact same thing. Where does setup tools get the fpic?
That's a good question.
Cannot find pick in setup tools. I even have distutils. So there's
Python is not coming into the picture here, right?
Python is no. So the fpic was in compiler parameters. So this should spawn compiler SO with CC flags, source dash O object, and extra boss args.
That was before.
So the CC args probably have the fpic. Where do you get CC args?
Distutils, compilers, base.
Get CC
Maybe.
args. So you get pp opts and then dash c. Yeah, we do have a dash c. So we need pp opts. What's a pp opts? Gen preprocess options. And C preprocessor options. DUI.
But this is not one of those DUI.
Right. So we go back to what was it called? CC args. Oh, CC args. So was it part of the compiler SOCXX, which is generated by compiler fixup? Oh, that's macOS compat, so that's probably not it. And compiler's SOCXX is C++. So they're just compiler SO. Oh, this is for C++. This is the same thing for C. So this will be either in compiler SO or CC args, right?
Mm-hmm.
it looks like that should just be the base name here. This due to sysconfig. There's another part of the maze here. What is this? Customize compiler. It's platform-specific customization. Information that varies across Unisys and is stored in Python's makefile. Good. There we go, there we go. So this is where we get the C flags and compiler SO. So the compiler SO consists of CMD and CC shared. So CMD is CC and the C flags, and CC shared is CC shared here. Okay. What is CC? So that will be in sysconfig.
No.
There it is. CC shared. Okay. I guess that's an upstream bug then. It's my problem and I shouldn't have done it here. Alright, hopefully you don't have anything more interesting to Fedora. Well, that's something to do for something to come up with for next week.
Yep.
All right. Well, thanks for sticking with me. Is there anything you'd like to ask?
I don't have anything in mind. I will read through the tutorial like more in depth, kind of jumping through the pros. I'll take a look if it's clear to me, and
Right.
it was interesting to see not such a long page with everything.
Well, it's not
Going.
everything. So that's the problem. As it says right at the start. Where were we?
Don't do this way.
It will not teach you important concepts like error handling and reference counting, which are covered in later chapters. And the later chapters are, everything else you need to learn to make your first extension do something else than the very, very basics. And eventually I'd like to rewrite parts of this as well. Hopefully I'll get some time for it.
Yeah, but that looks cool. That looks really well.
Yeah, so the next chapter after that should be
Setting exceptions.
probably
Or-
errors and exceptions, and
Mhm.
then reference counting, and that's like most of what you need.
Uh-huh. Twin eyes. That's a very catchy
What?
header. Like in the menu on the left side, there is a link called Thin Ice.
Thin ice. There are a few situations where seemingly harmless use of borrowed reference can lead to problem.
Mhm.
Yeah.
Mhm. Okay. That's even more. Cool, cool. Looking forward to the improvements to the docs. I will go through it and try to come up with places that are unclear.
Thanks. I'll try to get fpic into the configure script.
Good luck with that.
Not really my area of expertise.
Can this be an easy change to perform, or will it require more discussion?
I don't even know how the config here, like Python config, is generated. I guess I'll need to look in the make file. Python config. So it takes python config.in and runs set on it and runs another set on it. And that's it. Okay, so misc python config in. Yeah, that's the script. So C flags. So there's this option called embed, which you should use if you're embedding Python, and it has effect on libs. And I guess that's what should be used in C flags as well. So if you use embed with C flags, it should put in the CC shared as well. I wonder if we have the shared option. Oh, GCC fpic shared. This is interesting. Somebody's already using GCC directly in the test suite, but
Mhm. 。
but that doesn't include any any Python. So that doesn't really help us. What is this? How do I find unpunchies? Most more symbols built in your pure virtual. Ah. FAQ part of the documentation. That's just a very big mess. Anyway, I don't know where anything's getting the shared option from, but I guess I'll figure that out by myself. So if you have something Fedora specific for next time, that would be great.
I'll try to produce something.
And, yeah. See you next week. Oh, there's one thing we could talk about, and that's my new copper repo for old Pythons.
Oh. Okay.
If you don't have anything else. Right, so see you next week.
See you. Thank you for today.